So yesterday we talked about how we can use functions to describe the areas of geometric objects. As you will recall, we talked about a cube, which has a length, a width, and a depth, or a height, that are all the same. So we can call the area of a cube the length cubed. Now today, what I'd like to talk about is how we can use that same idea to talk about a circle or a cylinder. So, first, let's talk about the area of a circle. And I'm hoping you guys remember that a circle, or the area of it, is equal to pi times the radius squared, with the radius being a line coming from the center directly out. Now let's talk about why that is. And to do that, I'd like to refer to this circle as a pizza. So think of it as a pizza, and I'm going to cut it in half. I'm going to say that this half right here is plain, and this half up here is pepperoni. So now I'm going to cut that pizza into 8 slices, just like you would normally get it. So right now I've got 4 slices, 4 cheese, 4 pepperoni. So now let's imagine that we took those slices out, and rather than putting them in a circle, we're going to line them up. So right here I've got 1, 2, 3, 4 slices of cheese pizza lined up crust to crust. Now on the top, I'm going to take those 4 slices of pepperoni and I'm going to put those in. So there we go, I've got 8 slices, 4 pepperoni, 4 cheese. And what I'm hoping you're recognizing here is that we've got something of a rectangle. And if we look at this, we can see that the height of the rectangle is equal to the length of one of the sides of the slices of pizza. And if we look back at our circle here, our whole pie, the length of each side of that slice is 1 radii, r. So right here we know that the height of that rectangle is r. Now at the same time, we've got this width here. And let's see if we can figure out how big that is. So you'll see it's the length of all of the pepperoni slices lined up crust to crust. And so if we look at our circle, that would be 1/2 of the circumference. So if we took our circumference, which is equal to pi times 2r, or pi times the diameter, right? So 2 radii equals 1 diameter, or again, pi equals 2r. And we said, you know what? It's only going to be half of that. So let's divide by 2. So what I'm left with here is pi r. So the length of this rectangle is pi r. And as you guys know, if I wanted to find the area of a rectangle, I'm going to take the width times the height. So pi r times r equals pi r squared. So essentially what we've done is we've just taken a figure that we know really nothing about, and we've translated into something that we do know something about. So let's take the same approach to a cylinder. So if I had a cylinder, it looks something maybe like this. Well, I'm not exactly sure how in the world I'm going to calculate the volume of that cylinder. But if I think back to a rectangular prism, so here's my rectangular prism. The length times the width times the height is going to give us the volume of that rectangular prism. So think about what we're doing there. We're taking the area of the square at the base and we're multiplying it by the height. Well, we can do the same thing with the cylinder. We can find the area, which, keep in mind, is two-dimensional, and we can add that third dimension, the height. So let's say that we had a cylinder here, and let's say that the radius, so pretend this is the radius, is 2 centimeters. So I could say that, well, the area of that circle is going to be pi times 2 squared. And then let's say that the height was 10 centimeters. So the area of this circle is 4 pi. And then I'm going to factor in the height, how tall it is, which is 10. So that means that the volume here is 40 pi. And with pi being 3.14, you can figure out that our volume is going to be right around 124 and change cubic centimeters. Now, one thing that's really nice about the metric system is how easy it is to switch between units. So cubic centimeters are actually the same as milliliters. So we can say not only is this 124 cubic centimeters, but it's also 124 milliliters. And milliliters is something that's much easier to measure. So we could actually take this cylinder, if it existed in real life, we could fill it with water, and then we could pour it into another cylinder or some other body that we can measure the volume of water with and confirm that our measurements are correct.